Hey, it's Mr. E here, and our aim for this video is how can we use Pascal's triangle to help us expand the binomial. And this is part 2 of our binomial expansion series using Pascal's triangle. So here is our first example. Expand 2y minus 1 to the 6th power. So what we're going to do is first follow the steps that I gave you on the first video. And you should copy these steps down if you don't have them, because these are the steps I'm going to be following them. Step 1 is to determine which row will give you the coefficients based on the n. So n is the exponent that you're raising the binomial to, and a is the first term, and then b is the second term in the binomial. Alright, so since we're raising to the 6th power in our example, this is the row that's going to give us the coefficients. So what we're going to do now is write out the coefficients, and we're going to leave some space in between, because we're going to be writing in between these coefficients our a and b. So remember what I said earlier, a is the first term, b is the second term, and n is the exponent. Alright, so we know that with each successive a, the exponent is going to be decreasing, beginning with n. So we're going to start with 6 and then decrease 1 with each successive a. That's the pattern that these binomial expansions will always follow. So you begin with n, and then you just decrease by 1 with each successive term until you get to 0. With the b, you're beginning with 0 and you're increasing by 1, so you're ascending. 2, 3, 4, 5, and then 6 here. Alright, so now all we have to do is simplify this. So negative 1 to the 0, that's just 1. And now 2y to the 6. So let me explain this here. 2y to the 6, what you're doing is you're raising 2 to the 6th power, and you're raising y to the 6th power, so that you actually get 64y to the 6, because 2 to the 6 is 64, and then y to the 6 is y to the 6. So you get 64y to the 6 times 1 from here. This is 1. And then you have the coefficient of 1. So it's just 1 times 64y to the 6 times 1. And that's just 64y to the 6. Okay? So now here, negative 1 to the 1, that's negative 1. 2y to the 5th, that's 192y to the 5th. And then times that by 6. Oh, excuse me, I apologize. 2y to the 5th is not 192. 2 to the 5th is 32, so it's 32y to the 5th times negative 1, and then 6 times 32y to the 5th, that's 192y to the 5th. So I jumped a step there, I apologize for that. So let me just repeat that just in case I confused you there a bit. So negative 1 to the 1, that's negative 1. 2y to the 5th, that's 32y to the 5th. And then just bring the 6 down, then just multiply it all out. 6 times 32y to the 5th times negative 1, that gives you 192y to the 5th. So this is all just arithmetic from here. And if you just work it all out, you get these terms. So this is your final answer. One of the things that you'll notice is that when you have a positive A and a negative B, that the signs are alternating. I don't know if you noticed that. The first term is positive, the second term is negative, first term is positive, excuse me, first term positive, second term negative, third term positive, fourth term negative, and then so on and so forth. So the signs are alternating. Okay, let's look at another example. What is the fourth term in the expansion of y minus 1 to the seventh? Okay, so this is a little bit of a relief. They're not asking us to expand the whole thing. They just want us to give the fourth term. So if we use Pascal's triangle to get the coefficients, these are the coefficients when you're raising a binomial to the seventh power. And they're just interested in the fourth term. So I'm just interested in this coefficient right over here. So it's going to be 35. My A is y, and my B is negative 1. So I have to think about what the exponents are going to be. So I know that it's going to go, so I know that, for A here, it's going to have to start with 7, and then here it's going to be 6, then here it's going to be 5, and then here it's going to be 4, so I know that y has to be raised to the fourth here. And then I know that for B here, it has to start with 0, then B has to be raised to the 1 here, then B has to be raised to the second, then here B has to be raised to the third, so it's going to be negative 1 to the third. So all I have to do now is just simplify this, and I get my fourth term. So negative 1 raised to the third power, that's negative 1. So it's negative 1 times 35 times y to the fourth. That's negative 35y to the fourth. The answer is choice 3. Okay, now you try it. What is the fourth term in the expansion of 3x minus 2 to the fifth power? Okay, I hope this video helps. Take care.